Welcome, everyone. Welcome to this free webinar, AWS Discovery Day. Today's topic, we'll be dealing with Introduction to Securing Your AWS Cloud. Let's get started. Securing your AWS Cloud. So let's begin with some of the benefits of the cloud. We talk about the benefits of deploying workloads, applications, databases, and other things to the cloud. We talk about one elasticity, meaning the ability to say, adapt to changing traffic demands, being able to add more capacity dynamically as necessary to meet the current demand from your customers. We also discuss increased speed and agility as a benefit of the cloud because I don't have to wait long, provision times. I don't have to wait long times for putting in a requisition for your new hardware or database or something and waiting for the new hardware to be purchased and installed in a data center and set up and updated. In enterprise environments, that could take several weeks, several months in some cases. If I'm a developer and I want to work on a project, we have a new team, we want to work on a new project or some sort of experiment, perhaps, I can very quickly set up a new environment in the cloud using automation tools. We have an entirely new environment set up within a few minutes. It's very easy to deploy an architecture as necessary for some development project, for example. Also, we have the ability to go global in minutes. Currently, AWS has approximately 34 regions available around the world, allowing you to deploy application in specific parts of the world, maybe to be close to your customer base. If you have a large customer base in Europe, you can deploy your applications in Europe. There is the pay as you go, pay on demand strategy. The payment comes in the form of a monthly bill from AWS. Pay only for the resources you've used during that time period. And also many different forms of security. So we'll be focusing on that here in this presentation, of course. Various ways and multiple layers of security available with AWS. So it starts first with your AWS account. When you create an account with AWS, and anyone can create an account, doesn't cost anything to create an AWS account. You create an account, you have a user we call the root user. Root user is the owner of the account. That's the only initial user. They own the account. It's the only user where there's some personal information associated with them. You create an account, you'll need to provide an email address and a credit card number and so on. But one of the best practice from a security standpoint, is that you do not use the root user for the day-to-day management of your AWS account. The first things you'd want to do, you logged in as root after establishing the account. You would create another user using a service called IAM. We're going to talk more about that coming up. The Identity and Access Management service. You create an IAM user, and then you log in as root, log out as root, and log in as the IAM user to do further management and deployment of your resources in your AWS account. The account is what is billed. So every account is, of course, billed for the services they utilize, depending on what it is they've deployed in AWS. More about IAM coming up as we get into some of our additional security topics here. Another thing we work under when we're dealing with cloud type environments is this shared responsibility model, where AWS, look at down here at the bottom of the diagram, look at this. AWS is responsible for security of the cloud. And you are responsible, you as the customer, you're responsible for security of what you place in the cloud. So as far as AWS is concerned, they have the responsibility of securing all the physical locations, the regions, the availability zones, which contain the data centers, the other hundreds of edge locations around the world, all the physical security and access control that's AWS's responsibility. And then AWS is responsible for securing and managing the underlying hardware, all the compute resources, and the hardware that supports the storage and hardware that supports your databases, all the networking environments. From a physical perspective, managing, you don't have any access to that. That's all AWS's job. On the other hand, you as the customer, you're responsible for what you put in the cloud. So operating systems you deploy, on EC2 instances in the cloud, the operating systems, user data that you put in the cloud, your application code, etc. Your responsibility to make sure that's secure through various types of encryption. We'll talk more about encryption coming up here in this presentation. Firewall, your network traffic protection with firewall configuration and other type of network security tools. Updating, patching the operating systems on servers you might be running, security vulnerability patches introduced, for example, it's your responsibility to install those on your servers and proper access control and authentication options, primarily with the IAM service, like we will be discussing more of here in just a minute. But you're up to your responsibility to make sure that your users who are working with configuring your resources in AWS that they have the appropriate permissions, right, allocated to them to manage the resources on AWS. So let's look at some security design principles. One of them, basic design principle when we talk about security, especially when it comes to authorization or the permissions. One of those principles is the principle of least privilege. So you grant access as needed. So permissions that a user has assigned to them. And this would be the IAM service, where we can control not only authentication, but also authorization. What is a user authorized to do on AWS? And you don't want to give a user any more permissions than is necessary, because that just opens up unnecessary security issues, possible security holes and vulnerabilities if there are more permissions than required allocated to a user. We also want to avoid long-term credentials. Make sure that we have credentials like a password, for example, and we have to change that periodically. We will see also with IAM a best practice for you to add multi-factor authentication to an account. So they may have to provide, if they were logging in, provide a username, provide a password, as well as a code that changes every 30 seconds from an app on their phone or a hardware token of some type. Always a best practice in enabling MFA. Another security principle, enable traceability. I mean, one that will include monitoring access, actions, and changes, such as changes to your various resources you've deployed on AWS, whether it's an EC2 instance, perhaps, or some storage service we're utilizing. You'll monitor and be aware of changes to the configuration that have been made there. And there's some tools for that monitoring the actions and the changes. There is a service on AWS called AWS Config. The config service, which can be used for tracking the configuration of resources you've deployed on AWS. There's auditing in the form of another service, Cloud Trail. Cloud Trail on AWS is the audit log, audits and records and logs all actions that happen in your AWS account. And then other logging, it's like logging for systems, like again, your servers, like EC2 instances and other services on AWS. System type logs, performance metrics that is covered by a service called CloudWatch on AWS. CloudWatch is our say, performance monitoring and metrics, as well as logs from other services that you're utilizing on AWS. Many AWS services pre-configured to automatically send their logs to CloudWatch, and you can customize things too, such as customizing EC2 instances to send their logs, like operating system logs, say from a Linux server. That can be customized, so they send all the logs to the CloudWatch service. So you have your logs in a central location available to you. Other securities, defense in depth. Security at multiple layers, especially if we're talking about network type security. We'll see there are various services available. We'll see some of these in later, but briefly, we have from a network standpoint, network access control lists that can filter traffic inside your network on AWS. Security groups, which is also another layer of filtering. There is a service, the Web Application Firewall service. There's a service for a DDoS mitigation that you could implement in the environment. There is a there's a service called Network Firewall service for firewall policies and IDS, IPS, type of configuration we can implement, as well as optionally, in if we're talking about servers, you're running a host operating system firewall of some sort. Like you might have Windows firewall on a Windows server, for example, or some other firewall software running on a Linux, Windows, or Mac OS you've deployed on AWS. Automation is also an important part of security. We want to eliminate the possibility of mistakes being made by a human anytime we're manually configuring something, especially if we're manually configuring security settings. Mistakes can be made. So we could have across multiple say, servers we've deployed, could end up having security configured in different ways for different servers, which is not a good situation. We want some consistency, consistent deployment, consistent configuration, automate security type configuration as much as possible. So it eliminates that possible variations in securities, as well as automating responses to, say, events that happen. So we can use a number of different tools like we referred to previously. You've got Cloud Trail, for example. Cloud Trail is logging all these different sort of events and log messages. You could have a message that is written to Cloud Trail. That message can be set up so that we could take some action on something as we see a certain event occur. It gets logged by CloudTrail. That could trigger some other processes in AWS that allow you to automatically respond, such as isolating a server that maybe we've detected that the server has been compromised to some extent. So automation, the configuration of your resources, automate other routine tasks so we can eliminate mistakes, which can open up security holes. So automation supported in a number of different features. There are automation features in a service on AWS. There's a service called System Manager. which has a large number of automation documents, some pre-configured by AWS. We could have automation documents that say install patches on your servers, for example. And then you can make your own also, make your own automation documents. And then turning infrastructure into code again for deploying many types of resources in AWS, not doing that manually, which could lead to settings that are missed and whatever you deploy is not as secure as it could be, perhaps. Turning infrastructure into code to the actual architecture and resources we're deploying, all automated, and that's can be done with a service known as cloud formation, which can be used to deploy wide variety of resources on AWS. Can also protect data in transit and at rest. So we're looking at various forms of encryption. You can use encryption and other access controls. We'll talk more about encryption coming up here. But you can encrypt data that you're storing, you encrypt your storage, encrypt your databases. We'd also want to encrypt traffic that's in transit, like you would for your website, for example. Having your certificate on your web server and allowing your encrypted sessions to be set up between the clients and your web server. Also, AWS has support for an extensive system of tagging. Tagging is essentially metadata or a key value type of pair that you can associate with the resources you deploy. And the tagging can be used to perform a number of management operations. We can perform operations based on the value that's in the tag or the name of the tag, the key. You could use tagging to classify your resources you've deployed as to what is the your security sensitive nature. How sensitive is this particular resource? Is it intended to be a public resource? Is it private? Is it confidential? Is it top secret? All that can be conveyed with tags. And the tag values can be used with a top secret tag, for example. I can use it to run automated tasks like security reviews of resources that are tagged top secret, run an automated security review to make sure it conforms to our expected configuration and security configuration specifically. Also, we want to prepare for security events. We want to prepare for events because things will happen, incidents that happen, breaches of the network or attacks, like maybe attacks against a web application or DOS attacks, denial of service attacks against our infrastructure. And we need to have set guidelines in place. We need to have our processes, our documentation, so we know how to respond to incidents when they happen. We can automate much, if not all of this, have automated responses to incidents where we can automatically isolate a server that's found to have been compromised in some way. Or the worst case scenario, if resources are compromised, data is deleted, damaged, destroyed, that we can get up and running again from our backups, restore our data, deploy a new architecture as necessary, which could all be done with automation tools. Of course, deploy our new architecture, restore our data to that. Another security principle would be minimizing attack surface, meaning not unnecessarily exposing services, exposing certain port numbers perhaps on a server when it's unnecessary for that to be exposed, especially to the public. Minimizing attack service could uh, be implemented with things like firewalls, of course, to control what sort of traffic is allowed to connect to particular resources. And also in the case of things like denial of service attacks or distributed denial of service attacks, We could, to some extent, absorb some of that attack, be ready to scale, make sure your application remains available. We can increase our capacity. Want to ensure our application services remain available to our legitimate customers, even if we're experiencing a DDoS attack. So let's examine some more specifics here. We're going to explore what is your security posture. This is made up of many different pieces. We talk about a security posture for your AWS account, the resources you've deployed. One of those pieces would be authentication. Who are you? How do you improve your identity? So we talk about authentication. We are dealing with the IAM service, identity and access management. And this is where we have, several different components when it comes to IAM. We have users, we have roles, you have policies, and you have groups. Really the four sort of primary components, fundamental components of IAM. And let's go take a look at that. Let's go look at the IAM service here. So I'm logged into an AWS account. There's AWS console. And if we go look at IAM, let's go to the IAM service. And we can start by creating a user. So notice that here's the summary, get some summary information. Best practice, the root user should have MFA. Root should be set up with a very strong password and multi-factor authentication. Root is rarely ever necessary. There's a few tasks which only root can perform. So occasionally you might have to log in as root, like if you wanted to close the account, for example. Only root can actually close the account. But for everything else, we have IAM users. So if you go to IAM users here, and we'll create a new user. Create a user, and then we have to go through answer a series of questions. Do you wish to allow this user to log into the web console? You you want to provide them access to the management console, which means they're going to log into the web interface like you're seeing here. And do you want to actually create a user, or they're trying to steer you towards by default the identity center, which is a single sign-on or federation type of setup. That's what they would prefer. But no, I want to create an actual just independent IAM user. Set the password, let it auto-generate. We're not actually going to log in as the user. We'll just let it auto-generate. Click next. You want to put the user in a group. So you have IAM groups. A group is just it's like a container. A group would hold multiple users. And then we can assign permissions to the group so that every user inside the group inherits the permissions that are associated with the group. So it's a way of assigning permissions, granting authorization to a number of users with just using the group membership. So add the user to group. No, we're gonna attach policies directly. And then you have policy, which would be for this user, policy IAM policies are what contain the permissions. This is how we do the authentication part of that. More on that in just a minute. We're not going to assign anything. So by default, if I create this user, the user has no permissions by default because I didn't grant them any permissions here. And noticed the user had no sort of personal information, like no email address, nothing like that associated with the user. It's strictly defined in the IAM service. And you got the password here. It auto-generated. You'd want to show the password if you actually wanted to log in. You need to copy this, download it, save it somehow so you can do the initial login. And then, nope, no survey. Let's close that. So you have a user. Now you can put the user in a group. You can create user groups if you want to. That'd be the preferred way to manage permissions. You don't really want to manage permissions for an individual user basis. Let's go back to the user. And then another part of authentication here. Right now, the user has the username and the password, which can be used to log into the web interface, the console, like we're seeing here. And it is enabled currently without MFA. So multi-factor authentication is recommended. You can enable that here. If you wanted to enable MFA, you get to then select, oh, is there an application they're using? Is there a hardware-based, a time token, a token that's, only valid for a limited period of time, like 30 seconds perhaps. And you could enroll them in MFA here. So they need the username, password, and the code or one-time password is generated by the app or some hardware device. But also the the second type of permission here, or second type of authentication mechanism, is access keys. So with an access key, if we click on that, look at my options. If I was going to create an access key, I'm presented with a number of options. Access key is what you need if this user is going to be using the command line. There's an AWS command line interface you can download and install on a local workstation, for example. In which case you need these keys. At the command line, you don't log in with the username and a password. Or keys are also used for code or applications because everything on AWS needs permissions. Even an application you're running, it has to have permissions to use other AWS services. The various services on AWS need permissions to talk to each other when you're deploying and configuring them. And that's all really revolves around keys. And that's what you're looking at here. Generate a pair of keys. If I wanted to allow this demo user to use the command line, we need to create access keys. It creates a pair of keys. You would then need these keys to configure the CLI, the command line interface. There's an access key and the secret access key. You have to show it. This is the only time you ever get to see the secret access key. So it's going to complain now, I haven't viewed or copied the secret access key. So if I click done, it's going to complain because you don't get to see it again, in which case I need to create another key pair. If I don't view it right now, you never get another chance to see it. And then I'd have to delete the access keys and generate a new pair. So that's authentication. IAM users or federation, you might want to perform authentication with your on-premises Active Directory service, for example. And we can set that up also so that it integrates with IAM, allowing your users in your corporate Active Directory to get permissions to AWS. Then what about authorization? So authorization, permissions, privileges. What are you allowed to do? That is implemented through the policy. So let's go back to IAM. This time, let's look at policies. Number of policies which AWS has created and manages for you. That's all what you see listed here. AWS managed. There are some policies that are designed for particular job functions, so that's administrator level. And you can create your own policies also. Let's look at this administrator policy, for example, and it is very broad set of permissions. Policies look like this. Let me zoom in a little bit. Where there's the effect, allow or deny. What are we allowing? What are we denying? So the effect we are allowing in this case, what actions? And then you have wildcard, asterisk or star, meaning we're allowing any action on which AWS resources, any resource. Administrator level access, effectively do unrestricted access to everything on AWS. If you look at another policy, let's look for search for EC2, for example. And there's EC2. Let's look at this one, EC2 read only access. And we're allowing, what are we allowing? Allowing the action called EC2 describe. Anything that starts describe is like you want to view the configuration of an EC2 instance. This would be servers you've deployed, in the cloud with AWS. So that we're allowing the describe, which is like read on, just see how the EC2 instance is configured. And then which resource, meaning which EC2 instances are you allowed to view? In this case, wildcards or any EC2 instance. And then similar for what about the Elastic Load Balancing Service, ELB? Allow Elastic Load Balancing describe. And then metrics from CloudWatch. You're allowed to view the metrics for EC2 instances. And we're also allowed to describe or view auto-scaling setup for EC2 auto-scaling. So the IAM policies are what control the permissions. Permissions or privileges, and that's of course the authorization. Now, we also have um, different types of policies available. What we just looked at there is called an identity policy with AWS. Means that policy is applied to an identity like a user, like an IAM user. So it affects that particular user. There are also another type of policy known as a resource-based policy. Another level of permissions, for example, if we look at an S3 bucket, we look at an S3 bucket here, and let's go look at an existing bucket. Let's do this one. And you go to the permissions. You'll notice you have this section here called bucket policy. This is what's known as a resource-based policy. This policy is assigned to the resource, not the identity, not the IAM user. So this policy affects just this one bucket. And this is a policy which would effectively allow public read access, since this S3 bucket is designed to host a static website, static web app. So I would need to allow to public access read. They need to be able to read the files like, index.html or something. So that's what this is allowing. We're allowing principal, who's the identity. Well, wildcard. So allow any principal. What are they allowed to do? Get object version, which just amounts to read-only permissions to the content of the bucket. Which bucket? This one was the resource. This bucket, everything inside the static site web app bucket /star. But then there's the setting, as it's noting there, public access is blocked because you have the public access is all blocked by default on an S3 bucket. I still have that enabled. So that would take precedence over the bucket policy. So this policy is currently having no effect since the block all public access is currently enabled. Then what about monitoring? About monitoring, looking at monitoring the performance of resources you've deployed, looking at various metrics for your servers or storage or your database. So that service, whenever we talk about monitoring, we're talking about CloudWatch. CloudWatch has a number of different features available. With CloudWatch, we can Find metrics. It's performance information. What's the CPU utilization of your EC2 instance? How much storage are you using in your S3 buckets? How many reads or writes per second are happening on your database, etc. CloudWatch is also logs, a central location for logs. So resource or system type logs. You can send your logs from your servers to CloudWatch, other logs from other services. So if you're troubleshooting, looking for error messages and so on, CloudWatch would be the place to go. CloudWatch also has the ability for you to create alarms, or you could alarm on CPU utilization as one example. If the percentage, CPU percentage is greater than 75%, then take some action that could be used to initiate auto scaling. For example, add more EC2 instances, scale out your auto scaling group. And then CloudWatch also has events. Events. This is part of the events here, part of the automation, could be part of your automated response, like they're highlighting here, where we can set up a uh, an event when this event occurs, or we see a particular log message handled that's recorded by CloudWatch here. Some event with a service or a particular log message could then trigger some automated action, like an automated response, where we could automatically respond to some incident that's occurring, including error messages as well as configuration changes, things that have been made to my resources. So if you look at CloudWatch, find that in the go back over here to the AWS console. With CloudWatch, there's a variety of services that automatically deliver their metrics to CloudWatch. So if you look at the metrics, we have a variety of what are called namespaces, and those equate to a particular service like EC2. So if I look at EC2 instance here, for example, got 78 different metrics for the various EC2 instances in my account. If we open that up and scroll down, you will see metric names. So read and write, bytes, per second for my EBS volumes or my drives for my EC2 instance, CPU utilization, network IO, how many packets in and out, and bytes in and out of my network interface. And you can select metrics. You want to create a custom dashboard, we can do that. Select the metrics as necessary. They'll be populated on the graph here, as you see here in this example, though there's not anything to look at here for the moment. Then also in CloudWatch, logs. Look at logs. Logs are organized into groups. So you could have log files from various resources that make up a particular application deployment, like for your web application, your EC2 instance, your server, your database. And we could group those logs together. And that's what we're looking at here. We look at one of these logs, some logs for some Lambda functions. Click on that log group. And the log groups then contain log streams, which are logs from a particular source. So if I continue drilling down through here, click on log stream, and now we have some specific log messages for this is for a Lambda function on AWS, which is some code running, in this case, Python, running in Python 3.12, and information and log messages from that particular Lambda function. Then we have alarms. Look at an alarm. Alarms can be used to work with auto scaling. It's one of the things we use CloudWatch alarms for. When you want to auto scale your EC2 instances. So I could do that scaling based on the CPU utilization for various instances. So if just pick one as an example, where's my CPU utilization here? There it is. Pick a metric, and then you can select what are we looking for? Oh, if the CPU utilization on average over a 5-minute period is greater than 75%, then this could be used as a trigger to start auto scaling. Scale out, add more EC2 instances because all the current instances I have are, CPU utilization is high for all these servers. Then another type of logging. So we saw with CloudWatch, those would be things like your logs from your servers, other resources, other services you're utilizing on AWS, your EC2 databases, your Elastic Block Storage, and so on. Another type of logging would be the audit log, actions which have occurred on AWS. Now, everything on AWS, everything you do with AWS, maybe use the console, the web console to configure your resources on AWS, maybe using command line interface, maybe you're writing your own application code that interacts with other services on AWS. No matter what you are doing, no matter how you are doing it, web console, command line, other code, anytime you interact with AWS, everything is an API call. Even the console itself, is an API call. Using the CLI, it's all API calls. Your application programming interface that's integrated into everything on AWS. And the service that logs all of that is CloudTrail. CloudTrail has a continuous log, every action, every type of activity that has occurred in your AWS account. Doesn't matter how it's happened or which service it's occurred with, and CloudTrail's logging all of it. So with CloudTrail, you go through what's called configuring trails to log all of this. And let's go look at CloudTrail, find that. And with CloudTrail, I have, we look at event history. I have CloudTrail set up for this region, so I'm in the Oregon region, just logging everything that happens here. And here we have some entries. So earlier today, I was doing some things with DynamoDB. And here's the log entry regarding a deleting of the DynamoDB table. And there's an example of the event that's happened, recorded in a JSON format, JavaScript object notation, that an IAM user deleted the table. What they do? Event name, delete table, in which region? US West 2, so the Oregon region. They're using the browser, so there's the user agent, at the user agent header. I'm showing the browser. And what was the status? What was status? Table status deleting, which means my delete attempt was successful. Like then its status is showing the table is actually being deleted. And then it has some settings for the table. So you have in the actual CloudTrail interface, there's a limited amount of history, but you can set up CloudTrail. Like, so here's the trail for the Oregon region. You set up CloudTrail to also send the logs to an S3 bucket. That's what I have configured here. This allows you to have your virtually unlimited history of the activity that has occurred in your AWS account. So if I look at my current trail here, in this S3 bucket. Trails are set up per region. So a list of regions. Let's go to the US West too. So this is the Oregon region trail, and it goes back to 2021. You wanted to go back and see, oh, what happened in November? What happened November 22nd in 2021? You have a series of logs, and they're all zipped up. See gzip log files. They're all zipped up, so you can download this, unzip it if you wanted to view all the messages. But you can have your logs going back many, many years, allowing you to look into some activity or something that maybe happened several months or a year ago if you discover there was some breach that occurred, perhaps. Then what about encryption? Another part of security would be encrypting your data to add an extra layer of protection. And we're going to encrypt data at rest, meaning data that's in storage, whether it's at your database, it's a EBS volume, it's an S3 bucket. We can encrypt all of that data at rest. And we can also encrypt data in transit, like you would with your web application, for example, your web server, your website. You have a certificate and allow your customers to set up an encrypted session with your web server. When we talk about encryption, particularly we're looking at encryption at rest. You have the choices of, well, where's the encryption actually performed? If I'm of a encrypting the contents of an S3 bucket, if I set up S3, I could implement and utilize client-side encryption, which means I would encrypt the data on a local workstation or have some application itself that encrypts the data. Then it uploads it to an S3 bucket. The data has been encrypted by something outside of AWS before it's sent to AWS, like an S3 bucket, for example. So in that case, AWS doesn't really have anything to do with the encryption. Right? It's up to you. Encrypt the data and decrypt the data as necessary for your application to utilize it. Then there's server-side encryption. So client-side, let's CSE type encryption, server-side encryption, SSE, which means you don't have a choice anymore, but on the S3 bucket, encryption mandatory now. Used to be optional. Now it's mandatory. You create an S3 bucket, you enable encryption on that S3 bucket. So now as you upload a file, some type of object to that S3 bucket, the S3 service encrypts the file as it stores it in that bucket. And the same idea would also carry over for other types of storage. Your EBS volumes you're using with your EC2 instances, those can be encrypted. Databases, like your DynamoDB database, some relational database, like a SQL type database, those can all be encrypted on AWS. And then you have some options also when it comes to the encryption. Many services, such as S3, let's look at S3 as an example. Many services have encryption that is just built in as part of the service. So when I'm creating a new S3 bucket, if I scroll down, you'll see, oh, there's the encryption. And the simplest way I could do this is just use the server-side encryption. S3 has keys that it can use. S3 would take care of managing the keys that are used for the encryption. You don't have to worry about that at all. But then there's another option, server-side encryption with key management service, KMS, in which case, oh, now I have to select a key. So this is a separate service. This is key management service, KMS, where if I wanted to manage the keys myself, So let's go to key management service. I could manage the keys here myself if I wanted to, create new keys, specify other advanced options. Like if I needed to have a higher level of security, there's hardware storage, hardware security modules, cloud HSM service available. Generate the keys and actually store the keys in a hardware cluster on AWS instead of just being done by software. And you manage the expiration of the key or updating and roll over to new versions of the key as necessary. So we change it periodically. So you could combine that with KMS keys we use to encrypt things like S3 buckets or other storage, like again, your database perhaps. An option if you want to have some more control over the management of the actual keys. So protection at rest, encryption at rest. We use the keys that can either be built into the service, like S3, got its own keys that it would manage for you, or you can use KMS to manage those keys yourself. Then there's also the issue of protection in transit, which is making sure the data is encrypted when it's say, on the network. They're being transferred between a client and a server, for example. So you have data that's moving around AWS. If you were to replicate an S3 bucket from one region to another in AWS, that data is encrypted. All the internal private AWS infrastructure, all the traffic is encrypted there. If you had your own web application, if we had a website you were running on AWS, running your website here, then of course you can use certificates with that. Or what about VPN? Maybe you have a VPN connection into AWS, in which case we would have, depending on what type of VPN we're using, could be a web-based, like an SSL, TLS-based VPN. It could be IPsec also for a site-to-site type of VPN. And when it comes to services that could be involved, one of those would be certificate manager. If you are needing certificates, you have AWS issue certificates for your website. AWS is a trusted certificate authority. So your customers, clients, browsers trust those certificates issued by AWS. And you can also, in Certificate Manager, create your own a private certificate authority hierarchy if you needed to issue certificates for your own internal use for services, resources, servers you're running on AWS, not to be consumed by customers out on the internet. So it doesn't need to be a publicly trusted cert. You can set up your own private CA, issue certificates for a variety of purposes for the resources and workloads and applications you've deployed on AWS. And of course, when it comes to traffic, say like our web application traffic, we can ensure we're using encryption by only allowing HTTPS type traffic. Now, what about the data path? What about networking type security? What network controls do we have? Well, we have multiple layers of network type security and multiple services available to you with AWS. So we'll look at a VPC, your virtual private cloud, and subnets, and some other features. Here, let's look at the VPC setup first. So you would have with a VPC. VPC is a virtual private cloud. It's your own isolated area of the AWS infrastructure. And VPC security by default would include default security, um, traffic And resources inside your VPC are not public by default. No traffic allowed in and out of a VPC by default. Now, you can make things public if you wish. You can have a VPC communicate with another VPC if you wish. That's all up to you, necessary for you to configure, make configuration changes. But inside the VPC, the built in features, we have a VPC that would contain subnets. You have to create a subnet, at least one in a VPC. And then subnets all have their own individual routing tables. And that's how we go about creating a subnet that's either public or a subnet that's private. Part of that is controlling and setting up the routing, right? How is traffic how does traffic allowed to flow in and out of a subnet? You could allow traffic to flow to and from the internet from a subnet, in which case now it's a public subnet. And part of that involves modifying the routing table. If you want a subnet to be private, well, then you do that again through part of the configuration, including the routing table. We do not set up a private subnet with any path to the internet. So it does not have a route that would allow it to reach the internet. And then further, subnets have network ACLs. These are applied at the subnet level. They filter all traffic in and out of the subnet. So those ACLs is like packet filters. And then you have security groups. Another layer of security. Security groups apply to EC2 instances, specifically the interface, the Elastic Network interface that exists for that particular server, that particular EC2 instance. So you have multiple layers of security. And if you look at an example, look at a VPC. And I have a couple of VPCs here. VPC 1 and 2 in the Oregon region. Now let's look at subnets, particularly let's look at a public subnet versus a private subnet. So here's a public subnet. We examine the routing table. We'll see that here's the local route, it's 10.0, which is the IP address space for the VPC in which this subnet resides. But then there's also a default route. If the traffic's not destined for 10.0, then got my default route, 0000. The traffic is simply sent to the Internet Gateway, IGW. This is how you go about connecting a VPC to the internet, if necessary. You associate an Internet Gateway service. So I have an Internet Gateway associated with the VPC, and the existence of this default route makes this a public subnet. It has a way of now getting out of the VPC itself and out to the internet. So traffic allowed to and from resources like an EC2 instance. If I were to put my web server here, the public subnet, traffic is allowed to and from the internet by virtue of the internet gateway and this route entry you see here. If we look at a private subnet, on the other hand, go to private subnet, look at the routing table here. So same VPC. All we have is the local route, IPv4 and IPv6 also. Well, all the local route for 10.0. No route to the internet gateway. So no ability for traffic to flow to or from the internet for this private subnet. So any resource I deploy here, like an EC2 instance, it's all isolated from the internet. You have routing tables because you manage all the routing tables for your subnets here. These subnets have network ACLs. Let's go actually back to the subnet. And there's the network ACL list. So there's the list or for the private subnet. And the ACLs are generally, by default, the ACLs are going to wide open. Inbound rules, all traffic is allowed inbound. Outbound rules, all traffic is allowed outbound. But then you can further refine the traffic with security groups. Security groups would be applied to EC2 instances, which you deploy into a subnet inside of a VPC. So look at an EC2 instance. Here's one that's intended for Windows. Security groups have inbound rules. This one's allowing a remote desktop protocol, so RDP session from any source, or 3389 from any source IP. And there's also outbound rules, which would be for allowing this particular EC2 instance to initiate its own traffic outbound. The outbound rules allow traffic to any destination by default. Then you've got optional features too, some other optional security features you could add. Firewalls, the network firewall service. More fully featured a firewall policy setup. It goes far beyond what your security groups and network ACLs can do. And it also includes intrusion prevention and detection service. But that is additional cost for implementing the network firewall service. And then your choice also, you want to add another layer of security, some host operating system firewall that's actually running in the operating system of the EC2 instance itself, like you may have Windows firewall or IP tables for Linux, something along those lines, which would be another layer of security that would be up to you to manage, because that's not right an AWS service. Depend upon what operating system you're running there. All right, so we have reviewed authentication, which we implement with IAM users, including passwords and keys. Then there's authorization, permissions and privileges, which is IAM service once again, but this time is IAM policies we're talking about for our authorization versus say, users we have with IAM. Then the monitoring your logs, your metrics. We, of course, have the CloudWatch service available to us for various types of monitoring and logging on AWS. Audit logging, audit trail. Everything that happens on AWS is an API call, all logged by the CloudTrail service. Then encryption at rest, encryption in transit. When we're dealing with encryption at rest, like encrypting storage, that may involve, if you wish, you managing your keys with the key management service. Encryption in transit, maybe we need certificates for our web application, so the certificate manager service on AWS for that. And then network controls, security for your network. So in your VPCs, subnets, your network ACLs, security groups, other host firewall running on your operating system, optionally network firewall policies like we saw, and there are additional services too that we didn't really touch on here, but there's a service, for example, it provides web application firewall functionality for your deep inspection of your HTTP traffic. Defend your web applications against web application type attacks like cross-site scripting and SQL injection and other things of that nature. So what are my next steps? There are your courses, number of self-paced courses available from AWS. that you could take advantage of. Find those online. And we could other classes you can enroll in, classes, instructor-led courses from AWS. Or if you go to AWS's site, aws.amazon.com, and look for ramp up guides, you find a wide variety of what they call ramp up guides covering a variety of topics like this. There's our ramp up guide reference list. And they have broken down by role. Are you a solutions architect, developer, cloud operations, or solution, which is if we're looking at specific services. Part of what we are discussing today falls under the heading of cloud operations, sysops or systems operations, especially when you talk about automation things. That's a lot of sysop type content there. So many resources available to you to get further your studies when it comes to securing your AWS resources. That will conclude the presentation. Thank you everyone for attending. Thank you for taking the time to listen.